Hello everybody, today we will complete our chapter. It's lesson 2. It talks about translations. Translation is a transformation where all the points of a figure are moved the same distance in the same direction. By the way, translation is also one of the types of isometries. Isometry means you will not change the shape, you will not change its size, you will not change its length, the length of it. You will only change its position, its place. That's all. Okay. Like reflection. We took the reflection before. But now we will talk about the translation. Shifting, drifting, dragging, whatever. Okay, look at this shape. This shape, if I want to translate it, I will translate it with the direction of this vector. This is a vector with its direction, so I will move the whole shape in this direction. But if he asked you to translate along this vector, you will find how much is the length of this vector, then you will move this at the same direction, in the same direction of the vector, and you will move the same distance as the length of the vector. Look at the length of this vector, you will move the same distance in the same direction of the vector, like this one. It will be somewhere here. Also, if he said along this vector, you will find its length, then you will move it. If it is like this, you will move it in this direction and the same distance as the length down there, like this. Or if it is like this one, okay, you will move it, you will find the distance of this, the length of this vector, and you will move this shape to the left in the direction of the vector and the same distance as this. Look at all these vertices, they moved at the same distances and in the same direction. All of them changed the same distances, the same direction. This is the translation. Okay, let us take this example. Tell whether each transformation appears to be a translation. Like this. Look, this triangle. This is the pre-image and this is the image. Or whatever, if you want to make this is an image and this is the pre-image and this is the image, it's okay, no problem. Is this a translation or no? Look, if you move this triangle in this direction, it will be matched this one. So this is a translation. You can make the distances from this point to this point. You can find the distances, the length of this line segment, connect this point with this point, and this vertex with this vertex, and this vertex with this vertex, and find the distances. You will find them. They all, if you draw these line segments like this, and from here up to here, and from here up to here, you will find all of these line segments are parallel to each other and they have the same length. That means this is a translation, this is a translation, this is the image and this is the pre-image, or vice versa. Look at this one. Is this a translation? It's obvious that it's no, because if you if you moved this shape to the right, it will not be matched to this one. Okay, this looks like to be a reflection, it's not a translation. Okay, and you can make the same thing as we did here. Draw from this to this, and from this to this, and from this to this, and from this to this. You will find all the line segments are, yes, they are parallel, but the distances are not the same. Look, this distance is different than this distance, so it is not a translation. That's all. Okay. There is what we call translation vector. What is the translation vector? Like this, which I showed it before. Translation vector, it is the vector. It is the vector which you do the translation along it. And don't forget that it will be the same length of the vector and the same direction. The same length of the vector, you will move as the same length of the vector and parallel to the vector in the same direction. That means parallel to the vector. Okay, let us do this example. Draw the translation of the following triangle along the vector V. Along vector V. Vector V, this is the symbol of the vector. It is vector and an arrow above the V. That means this is a vector. I drew it here. This is the vector, and this is my shape, which is triangle. Okay, if I name this ABC, look what I did. From these vertices, which are the A and the B and the C, I drew these line segments, in the same direction of the vector V. Look, all of these line segments are parallel to this vector. Now I will find the distance or the length of this vector. I will find its length. Its length is about 3 centimeters. So I will move from each vertex distance with 3 centimeters from C in the same direction here, and this line segments. Okay, it is about 3 centimeters. It's here, the first one. So this is C dash, and the same as for B. B dash, and for A the same distance in this direction. It's here. Then I will draw my result or the image. This is the image. This is the image of this triangle. Look, it looks like if I translate it in this direction, they will be match each other. So this is the image for this triangle by translation along the vector V. Okay, now we will talk about how to draw translations in the coordinate plane. Look at this example. Translate the quadrilateral with vertices A. These are the vertices for this quadrilateral. Along the vector, this is the vector, it's given, its coordinates. The coordinates of this vector are given. This is the x coordinate and the y coordinate. That means you will move 2 units to the right in the same direction of the x-axis to the right, and the 3 units down. This is for y. So x and y. This is the symbol for the vector. It's like this one. Okay, so this is our vector. You can name it any name, VW, whatever. Now what I did here, this is the xy plane, and I plot all these points which are given, A and B and C and D. A is 2, 5 here. I plotted it here, and B and C and D. Now I will make the translation for this along the given vector, which is 2 and negative 3. Now you can make this table. This is the pre-image for all vertices of the quadrilateral, A and B and C and D, and you can get the image by changing the x coordinates and the y coordinates depending on the given vector. So you will add to the x coordinate for each vertex 2 units and subtract 3 units from the y. So add 2 units to the x coordinate and subtract, because this is negative, 3 units from the y coordinate. Or you will move 2 units to the right and then you will move 3 units down. So what I will do here, look, 2, I will add 2, so it will be 2 plus 2, and for the y, which is 5, I will subtract 3. So I will get, this is the image for the vertex A. It is 4, and 5 minus 3, it is 2. The second thing, which is B dash 0, I will add 2, and the 2 I will subtract 3, so it will be 2 and negative 1. This is the image for vertex B, which is B dash. For C, it is 1 plus 2 and negative 1 minus 3. You will get 3, the x coordinate, and negative 4. This is C dash. D dash, the same thing, 3 plus 2 and 1 minus 3. You will get 5 and negative 2. So these are the images for these vertices. I will plot them there. A dash, it will be 4 with 2. 4, 1, 2, 3, 4, and 2. This is A dash. B dash, it is 2 and negative 1. 2, 1, 2, negative 1. This is B dash. C dash, it's 3 and negative 4. 3 and negative 4. 1, 2, 3. 1, 2, 3, 4. So this is C dash. And D dash, it is 5 and negative 2. So D dash, it will be 5, 1, 2, 3, 4, 5, and negative 2. 1, 2. This is D dash. Now I will connect between these 4 points to get my image after the given translation. I will draw it with the black color. So this is the image for this, by the translation, the given translation along this vector, which is 2, -3. Thanks for watching. Bye bye.